Immunity.
Okay, now you're solving for v as a function. Okay. Now, before I posted this question, if I gave you an expression for acceleration, any generic function for acceleration, how would you find the formula for velocity? What would you have to do?
Just take the integral.
You'd have to take the integral. Okay? You take the integral with respect to what?
Time.
With respect to time. So what you do when you take a normal integral with respect to the power rule, you change a to dv over dt, right? That's what you're doing even though you're not including that step in your writing. And then you would just do the power rule for whatever followed. So, for example, if you have just free fall, you change acceleration equals 9.8 or negative 9.8. You change that to dv over dt equals 9.8, and then you would take the integral with respect to time. So you get v is equal to 9.8 t. Everyone with me so far? No? So sidebar.
You're in DC.
Yes.
Right? Okay. Now, looking back at our original question, does anyone notice a problem when we try to do that?
Yes.
What's the problem, Isaac?
G.
Nope.
B.
G is not the problem.
B.
V is the problem.
25%.
Okay? You have this variable v right here. You have to take the derivative, or you have to take the integral with respect to v as well. Okay? So this is going to cause a slight problem. You change it, you have dv over dt, just like you normally would, g minus bv. Okay? However, now you need to isolate v and isolate t, so that way they're all on the same side. So you would get dv over g minus bv equal to dt. That is not an integral that you have encountered yet in my class. And since most of you are here, I'm assuming you have not encountered this yet in calculus. Okay? Please take a look now at the formula sheets that I passed back to you. What formula on the calculus section does it look like you would use? So you have your 6 derivative formulas and you have your 5 integral formulas. Which of the 5 integral formulas does it look like you use?
dx over x plus a.
Which one? 1, 2, 3, 4, or 5?
3.
3. Okay? If you do that, so this, another simple trick is you can do substitution by parts, or you can just do a brute force. I'm going to do a brute force. So I'm going to take the integral, and I'm going to use that third integral right there. So if I do that, take the integral, this side simply becomes t. From 0 to t. Remember to include your limits. So 0 to b. This will be important later. We've been kind of lazy about it, because with the power rule, it tends to go away. But when you have natural log or sine functions, the 0 part may not go away, especially since we have this term down here. So then the natural log becomes ln g minus bv with bv term. 1 over okay. Now to check to see if I did the integral correctly.
Where do you get 1 over negative?
Right. So this is if I take the derivative of ln g minus bv, I'd have to pull up with respect to v, right? There's this extra term in here that I have to worry about. So in order for me to undo that, I have to include this 1 minus
Backwards
negative.
change.
Exactly.
Oh,
It's the reverse of the chain rule.
That's pretty cool.
Okay, so this negative b term would come out because it has to cancel out for me to get g minus bv back. Does that make sense? Questions so far?
Could you do like a quick recap of the last 10-15 minutes? No, it's like what you just wrote on the board.
Oh, just this on the board? This is a problem.
Well, no, I mean like the work below.
That was like 2 seconds.
No, just review that.
All I did was I looked at the back of the calculus section,
Mhm.
and I figured out which one of these fits with which on the formula sheet. Which one of these 5 integral formulas match up with what I'm trying to do? And the only one that matches up is the third integral formula where it says dx over x plus a. So here, instead of x, I have v. Instead of a, I have g. And instead of x, I have minus bv.
So it could be seen like negative BB plus G also.
Yeah.
Wait, is it absolute value G minus BV?
Sure. It doesn't matter. It's a natural log.
So you took out
Girls.
you took out 1 over negative b because of change.
Yes. Because in order for integral is the opposite of derivative.
Yeah.
So I want to check to make sure that I did my integral correctly.
Yeah.
If I didn't have this term, right?
Yeah.
I would have a b come out when I did the derivative.
Oh, I see.
So in order for me to get g minus bv back, I need to be able to cancel out that extra b term. Does that make sense now?
Can you do G minus BV?
Can you actually do the derivative?
Be outside.
Yeah.
So
One. Divide negative B.
if I did this,
Yes.
right, with respect to v, I would get ln. What would I get? I'd get 1 over
1 over b. Wait, 1 over.
1 over A, B, C, D, E, F, Q,
English? What's that?
not Chinese. ¿Cómo te llamas?
This is what I get if I take the derivative.
Oh.
Right? So how do I cancel out this term in order to get this term? It needs to be positive, and I need to cancel out a b. So negative b. 1 over negative b. Because in order to do the derivative of this, I take the derivative of ln, 1 over x, and then I have to take the derivative of the inside of the ln. That's the chain rule.
We didn't learn the derivative of ln was 1 over x, which is why it was
Gotcha. So is that okay?
Oh,
Yes.
Oh, it's 1 over
Derivative
Yeah, it's a
Okay, bro. Okay.
Just calm down.
I need you to relax. I need you to relax, Bijan.
Take it easy.
Wait, so it's just ln? So I can just do
1 over
BV
x.
ln.
You just do whatever you want.
That's kind of cool, I guess. Alright, I'm probably gonna fail the test.
Derivative of ln x as a function is 1 over x.
Derivative of ln.
Everyone here?
It's
Everyone understand this?
1 over
This is a given on the calculus sheet.
But then also you
Okay.
Oh, it is.
This is something that in calculus you may have to memorize, but on my formula sheet, it's given to you. So knowing that then, and looking at your formulas, you can now understand that if you take the derivative of this, just ln g minus bv dv, you would get 1 over g minus bv, and then you guys all know the chain rule?
Yeah.
Okay, so then with the chain rule, you know that you have a negative b. So that's why you have to include this negative 1 over negative b term.
Because you have to cancel out the negative b. When you do the chain rule,
Chloe?
you end up with an extraneous negative b. If you have
Okay.
1 over negative b,
That's fine.
numbers on it.
So when you
130,
have
don't derive 130.
Things that are inlaid inside of each other, like you would have with a sine theta, where you might have terms inside of the sine theta, or like in this example where we have extra terms inside of the ln. After you do the derivative of what's outside the parentheses, you then have to do the derivative of what's inside the parentheses as well, and then you multiply.
Oh, okay.
That's the chain rule.
Gotcha, thank you.
Yep.
I don't think we're
Okay, guys, we're not done yet. Not even close. Okay.
better than Shamla.
So going back to our original problem here, okay, this is where we left off on step 3. Okay, so now, as you guys are aware, like we do with the power rule, you plug in your variables, okay, you plug in your limits. In this case, we have an undefined limit of v, and we have an undefined limit of t. That's okay. So for the t side, it just becomes t minus 0, because you plug in t to t minus the function. Everyone know this? No?
We just started.
You just started this?
What is
We haven't gotten to expansive integrals. We just learned what an integral was.
Okay. Alright.
I'm still on AB.
So what I'm showing you is I'm showing you the fundamental rule of calculus. Okay? The fundamental rule is that when you take an integral, you plug in your limits. The top limit is what goes first. The bottom limit gets subtracted. This is what you're doing whenever you're taking the area under the curve. Kevin.
That's how we find out what C is, right? No.
You can find out C this way, possibly. Or it can be given to you in the problem. Okay? It depends. Okay? So, sidebar. If we had x squared integral dt from, let's say, from 1 to 3. Sorry, not dt, we'll do dx. We have 1 over 3 x cubed from 1 to 3. So then what you do is you plug in 1 over 3, 3 cubed, minus 1 over 3, 1, 3 cubed.
8 and 2.
And what would you do with the?
Then you just simplify it. So then this becomes 8.
Yeah, but what do you do with the
Right?
8?
3,
8 and
2. It's 2.
Okay, so what do you do
No,
with
that's
7,
9 minus a
9.
third.
Oh, I was right.
8 and 2 thirds. 8. It should be 9 minus a third.
So then 3. Thank you.
Wait, so what do you do with the? Oh, that's a
That's
C.
your answer. That's an example.
Is that the C?
That's your area under the curve.
No, that's
No.
your area under the curve
Of
Oh.
hypothetical.
of a limit. This is a sidebar. So this is what you do after an interval. You plug in your limits. Okay. So with ours, we did define our limits from 0 to v and 0 to t.
Yeah.
So that's all you're plugging in. So I plugged in to t, and I plugged in 0, 0. Okay. Now here you have a little bit longer of a. So when you plug in 0 to this side, this goes to 0, but you're still left with a 1 over negative b ln g as your secondary portion. I'm doing this backwards to make sure I have enough space.
That's just raise. That's just raise.
Soda.
Okay, so I plug in v to this equation, that's what I get. I plug in 0 to this equation, that's what I get.
How do you define your limits at the top? Is it just implied that it's going to be to 0? Or?
Yeah, it's gonna be, well, it's told to us that we're starting off at t equals 0, and we're also told that the object is being dropped.
So it's at rest.
So it's at rest when it starts.
I love when my phone's out of ink.
Okay?
Have you tried getting more ink?
We try finding a pen.
So now it's easy.
Yes. Subtract log